HighBridge, a division of Recorded Books, presents The Age-Proof Brain. New strategies to improve memory, protect immunity, and fight off dementia. By Dr. Marc Milstein. Read by George Newbern. Publisher's note. In this audio edition, you will hear references to diagrams present in the print and ebook formats of the book. This book is for informational purposes only. It is not intended to serve as a substitute for professional medical advice. The author and publisher specifically disclaim any and all liability arising directly or indirectly from the use of any information contained in this book. A healthcare professional should be consulted regarding your specific medical situation. Any product mentioned in this book does not imply endorsement of that product by the author or publisher. Introduction. After I gave a talk about the latest science on how to optimize brain function, a man in the audience approached me. He told me he was taking a pill he'd seen in a TV ad, which claimed it would improve his memory. "It's absolutely amazing," he said. "What's the name of the pill?" I asked. "I can't remember," he replied. That just about sums up how effective those magic pills are. Yes, it's understandable that we're desperate for a quick fix to one of the greatest collective health fears we have, losing your memory and having your mind go from a high-functioning piece of biological wizardry to a lump of gray matter that struggles to remember what day it is. When I say wizardry, I'm not exaggerating. A healthy brain is an amazing thing. It can effectively learn, remember, manage emotions, analyze, make good decisions, create, and innovate. A healthy brain can also let you do the electric slide, laugh at people doing the electric slide, navigate, and hit a perfect golf shot. Well, sometimes. A functioning brain is essential for being the best version of you. Our brains do change as we age, and our mental functioning changes too. A youthful brain is more focused, can learn and retain more information, and is more resilient to many conditions. The average human brain shrinks by approximately 5% per decade after the age of 40. As you might imagine, a shrinking and shriveling brain can have a devastating impact on memory, focus, and productivity. What's more, brain disorders like Alzheimer's disease and mental health issues are on the rise. Many of us have witnessed the devastation of dementia and depression and have seen how they can rob our loved ones of being themselves. Worldwide, we're at a tipping point in terms of brain health. Consider these alarming stats about our day-to-day brain and mental health. In 2020, 54 million people worldwide had Alzheimer's disease or other dementias, a 144% increase in the last 30 years. In the U.S., 12 to 18% of adults over the age of 60 suffer from memory loss or cognitive problems. Among individuals with dementia, those who had a mental disorder such as anxiety or depression developed dementia around 5.5 years earlier than those without a mental disorder. Anxiety disorders, the most common mental illness in the United States, affects 18.1% of the U.S. population. That's 40 million adults. Depression is the #1 cause of disability in the world. In the United States alone, 16 million people, 6.7% of the U.S. population, suffers from depression. Approximately 1/3 of people in the U.S. who pass away after age 65 will die with some form of dementia. 52% of all workers are experiencing high levels of stress, mental exhaustion, and burnout. How can we stem the tide of these startling and terrifying trends in brain health? The pills, games, and brain teasers and secret solutions that people spend millions of dollars on, none of them will turn an aging brain into a healthy, youthful one. And these trends have profound implications. In our lifetimes, virtually every one of us will witness the effects of an aging brain, whether in ourselves or in someone we love. For me, I first saw it in my grandmother, Bubby Lorraine. How I came to care about brain health. Bubby Lorraine was laugh-out-loud funny, a professional artist, and a natural athlete. She could make an Eggo waffle taste better than any waffle I'd ever had. As a teenager, I watched that charismatic person slowly disappear as she began to suffer from dementia. In those days, doctors couldn't even tell us what type of dementia she had. Was her dementia due to Alzheimer's? Was it vascular? The doctors told us there was no point in looking further because there was nothing they could do. Bobby Lorraine's decline wasn't the only experience that got me interested in finding out more about the body. As someone who struggled with Crohn's disease since I was 9, I witnessed the difficulty practitioners had diagnosing my condition, and I became curious about how the body works. I started doing research in a genetics lab at the Salk Institute every day after school, beginning at age 15. At UCLA, I performed over a decade of lab research on topics from infectious disease to breast cancer to brain science, and I started to notice a pattern. In the last few decades, science and medicine have become very specialized, which can be wonderful in many ways. For instance, incredible discoveries from penicillin to gene editing to futuristic advances in surgery are scientific marvels born out of that intense focus. But that specialization has also caused a lack of perspective about the big picture. People tend to think of the body as a series of silos, isolating one system, organ, or process from all the others and making an absolute statement about what may be causing one specific symptom. But as we learn more about each body system, we understand they are actually very much connected. What happens in one part of the body strongly impacts another. The more I researched the latest studies, I started to have a clearer and more nuanced picture of how interconnected multiple aspects of our health truly are. After completing my doctorate, I had an opportunity at UCLA to give a talk on science to non-scientists. I hated the way science was typically taught. Boring, clinical, hard to understand. I wanted to share breakthrough research in a fun, accurate, and compelling way. That one talk led to another, and then another. I saw the powerful impact of delivering the latest research to people in an understandable way, and how the talks positively and dramatically changed lives. As I traveled the world giving talks on brain health, I was surprised to see that the questions people asked and the topics they wanted to hear about were the same in every country I visited. Across all cultures, generations, and economic levels, the same question was asked in a variety of languages. How do I live an optimal life? The Age-Proof Brain answers this question in this book. The good news is, serious mental decline is not an inevitable part of aging. For example, it is estimated that a third of all the current cases of dementia could have been prevented by changes in lifestyle. Day-to-day functioning, productivity, memory, and focus can all be maintained and strengthened throughout life. More and more research points us to a compelling conclusion and powerful message that we, not our genes, can have control over our cognitive health today and the destiny of our brains. In fact, research presented at the 2019 Alzheimer's Association International Conference found that certain lifestyle factors have a greater impact than your genes do on whether you'll develop memory-related diseases. In 2020, researchers at Rush Medical Center in Chicago found that those who followed recommendations for simple lifestyle modifications reduced their risk of developing Alzheimer's by nearly 60%. The keys to a healthy, youthful brain lie in the brain's connections with the rest of the body. There are 11 key factors to preserving and enhancing brain health: a robust immune system, a healthy heart, preventing or treating diabetes, treating mental health conditions, quality sleep, a nutritious diet, regular exercise, stress management, avoiding environmental toxins, social connection, and continually learning new skills. It is the nuances in these factors that may surprise you. For instance, sleep quality is more about getting effective sleep than just getting a certain number of hours a night. When it comes to exercise, we need to rethink the old saying, no pain, no gain. And enhancing your immune system isn't about boosting your immune response. In fact, that could do you more harm than good. And it's not about one of these factors in isolation, but the synergistic aspect of how they work together. The combination of these factors is critical for slowing down the negative effects of brain aging, realizing your brain's true potential each day, and protecting your brain from conditions such as dementia, depression, and anxiety. You may wonder what mental health has to do with brain aging. As we'll explore later, if they're left untreated, depression and anxiety can speed up brain aging. This is why I'm dedicating a chapter to each of these key factors, filled with take-home, actionable tips. You don't need to worry about the dizzying fads, sound bites, blurbs, and tweets that are often filled with misinformation. In this book, I carefully examine decades of research to distill the key take-home messages into accurate, actionable, and transformative habits you can keep. This book is broken into 3 parts. Part 1 offers a crash course on your amazing brain, how it develops and functions, and its powerful connections to your immune system, heart, and gut. Part 2 examines what surprising and often overlooked factors age the brain. Part 3 provides actionable solutions to keep your brain young and age-proof. When it comes to brain health, little lifestyle tweaks can have a profound impact. Unfortunately, there are false promises out there filled with marketing hype that are nothing more than a waste of money and are sometimes dangerous. But this book dispels the myths and cuts through the noise. You'll find a map to science-supported action steps, both big and small, that can help optimize your brain function each day at any age. This integrative approach will help stave off memory problems, fight off depression, improve mood, and boost day-to-day productivity and energy. It's an inoculation against dementia and non-genetic Alzheimer's. The action steps you take to protect your brain years down the road will also optimize your brain health today and tomorrow, so you can always be the best version of yourself. Plus, there's a bonus age-proof brain 7-day challenge to put these recommendations into action and kickstart your brain boost. Throughout the book, look for boxes titled The One Important Sheet of Paper. These recommended topics you can jot down on one piece of paper, which you'll bring to your next checkup with your primary care provider. Studies suggest that tracking these critical tests and keeping them within normal range plays a significant role in slowing down the aging of your brain. At the end of the book, you'll find that list collected in one spot. Make a copy or take a picture of it on your phone to take with you to the doctor. This book is not an anti-aging book in the sense that it is against aging. There are aspects of aging that are wonderful. We gain knowledge, experience, confidence, perspective, and wisdom as we age. For example, knowing what I know now, I would not have worn an all-white suit to my middle school dance. We want to embrace these aspects of aging. In fact, a study found that those who had a positive attitude toward their age and the aging process had a 49.8% lower risk of dementia, even if they had a genetic risk for Alzheimer's. The focus of this book is to slow down and delay for as long as possible the decline of the brain and body that often comes with aging. The goal is having a plump, clean brain and being happy, productive, and embracing life. We can get the best of both worlds. We can enjoy the natural evolution of our lives and live the best life possible. This book is for my Booby Lorraine and for the Booby Lorraine in your life. Even though their memories were taken, we will never forget them. I'm writing this book with the hope that we can use the latest scientific breakthroughs to lessen the number of times we all go through this type of loss. This book is empowering you to not feel resigned to this fate. You can keep your brain young. You can help those you care about keep their brains young, too. The age-proof brain will equip you with a new take on how to manage your lifestyle using cutting-edge information that can help you live a far healthier and prosperous life. It will help you feel like you can have your best days today, tomorrow, and into the future. Part 1. Meet Your Brain. Chapter 1. How old is your brain? Robert Marchand set a world record for centenarian cyclists when he was 101. Amazingly, even after the age of 100, he was still able to improve his speed. This centenarian would be classified as physically fit, even for a man aged 42 to 61. Clearly, we can make our bodies move as if they were younger, but what about how our brains function? And when do we even want to start thinking about our brain's age? I often hear people in their 30s and 40s comment that their brains aren't working like they used to. Maybe these people can't concentrate at work anymore, or can never seem to remember if they close the front door. Trouble focusing, diminished productivity, and difficulty with recall can be frustrating, but often these symptoms are brushed under the rug or just chalked up to stress. We all have our human moments, but don't downplay these signs until they reach a point where they cannot be ignored. No matter what your age, your brain health today impacts your brain health tomorrow. I'm sure you've heard the word senility. Many people use it to describe what happens when someone has reached a certain age and their mind, especially their memory, doesn't function like it used to. You may say, well, that's part of aging. There's nothing anyone can do. In fact, there is a lot you can do. If you take care of your brain properly, it should keep up with your body as you age. A sharp mind into old age isn't just a bit of luck. It's within reach for most of us. For instance, in some illuminating studies, researchers performed magnetic resonance imaging, MRI scans, on participants' brains. Some of the participants then implemented certain key lifestyle changes, the same ones you will find later in this book, in fact, and follow-up brain scans taken 6 months to a year later showed their brains looked younger than before. It was as if the participants in the experimental group had put their brains in a time machine. A younger brain is plump, with more mass of gray and white matter, or brain cells. The experimental group's brains had more volume and fullness. They were actually bigger, and there was an increase in connections between their brain cells. In contrast, the participants who didn't adopt these lifestyle interventions, the control group, had visibly older brains, which had reduced in volume since the study started. A shrinking brain loses functionality and is at risk of a long list of disorders. Think of your brain cells like tires. They need to be full to function. They're like a vibrant city bursting with activity, from building proteins to transporting molecules to replicating your DNA. It's like you have a bustling mini Manhattan in each of your brain cells. Your ability to think, remember, and innovate is tied to the vitality and fullness of each brain cell. If the cells collapse, these functions cannot proceed, and cognitive abilities suffer. The take-home message is just because you're getting older doesn't mean your brain has to age at the same rate. Significant cognitive problems are not a normal consequence of aging. Brain Development 101. To understand how your brain ages, let's take a moment and take a crash course on brain science to look at how your brain is built. I call this brain science in a couple sections, and the best part is there are no quizzes or tests. If you were to open up your skull and look down at your brain, the first thing you might notice is that it is divided into halves, separated by a long groove down the center. This entire wrinkly pinkish gray structure is called the cerebrum. The technical term for the halves of your brain is cerebral hemispheres, like the hemispheres of a globe. Just like your face has symmetry, so does your brain. Actually, what you're seeing is called the cerebral cortex, the outer layer of the cerebrum. That's what's often called gray matter. The inner layer is white matter, or substantia alba, which is made up of densely packed nerve fibers. We can further divide the cerebral cortex into lobes. There are 4 key lobes on each side of your brain. Each has a different job. The frontal lobe, situated at the front and top of the brain, is involved in thinking, decision-making, and controlling your movement. For example, if you're trying to learn the latest dance or to play chess, you are using the frontal lobe. The parietal lobe, which sits behind the frontal lobe, helps you process information from your senses. If you're walking through a theme park, all the temperatures, sounds, smells, and the feelings you get when you run your bumper car into someone else are being processed by your parietal lobe. The temporal lobe at the lower front of the brain plays a role in memory. This part of the brain also takes your memories and integrates them with your senses. In Chapter 5, we discuss how this insight into how your brain works can help you remember like a memory champion. The occipital lobe is at the back of the brain. Its main role involves vision. In the back portion of the skull below the temporal and occipital lobes sits the cerebellum, Latin for little brain. It plays an important role in movement, coordination, posture, and balance. Finally, there's the brain stem, the lower part of the brain, which connects to the spinal cord. It regulates vital automatic processes, like breathing and heart rate. There are many other brain structures with other specific functions, which I'll introduce in later chapters. The brain is a remarkably complex organ. For now, you've been introduced to the basic brain parts. Let's go a little deeper and talk about what the brain is made of. The average adult brain weighs about 3 pounds. Those 3 pounds are made up of about 80 billion brain cells, or neurons. To put the magnitude of your brain into perspective, if you could possibly count to 80 billion, it would take, wait for it, about 2,500 years of nonstop counting. How big is one brain cell? Think of the dot of an eye in this book. You could fit 50 brain cells in the dot of that eye. Here's a surprise. When you were born, your brain weighed about 3/4 of a pound. Quite a bit happened before you were born. In the 9 or so months of brain development you spent inside your mother, you were making a staggering 250,000 new brain cells a minute. That's a lot of work. But while your brain quadrupled in weight since then, guess what stayed the same? The number of brain cells. You have 80 to 100 billion brain cells now, and you were born with most of them. That's right. You've had most of your brain cells your entire life, and they were formed before you were born. Several parts of your brain can add new brain cells throughout your life, though. One of the important ones is your hippocampus, which is involved in memory. We will talk about the hippocampus throughout the book in order to keep this part of your brain healthy and to boost your memory. So, what created all that extra weight? For starters, the connections between the cells. Your thoughts, your feelings, your memories, the way you move, and every aspect of your being, essentially who you are all in the interaction of those cells. Those 80 to 100 billion neurons communicate by sending each other electrical and chemical signals through 100 trillion connections at their axons, the transmitting part of the cell, and dendrites, the receivers. By the way, 100 trillion is at least 1,000 times the number of stars in our galaxy. In fact, there is enough electricity running through your brain right now to power a light bulb. Maybe someday our brains will be powering our appliances. As your brain developed, you also added supporting cells like astrocytes and oligodendrocytes, also known as glial cells, which hold the neurons in place. And as you learn new things, you added myelination, a coating around your brain cells that makes the electrical signals travel faster. It is similar to the insulation you see on an electrical wire. This myelination allows us to get better at tasks and adds weight to the brain. Humans aren't born with much myelination, which is why babies aren't very good athletes or musicians. Fast facts about myelination. 2 things that increase myelination and improve brain processing speed: exercise and eating fatty fish like salmon. Why fatty fish? The coating that wraps around our brain cells is omega-3, which is found in fatty fish. This is why fish is called brain food. In Chapter 14, we will delve into which foods give your brain a boost. As the brain develops, a process called remodeling occurs when we learn new things. This process is most intense during our childhood and teenage years. It continues throughout the rest of our lifespan, but to a lesser degree. Much of that remodeling is happening in the connections between brain cells, which get stronger as you learn and remember information. These 100 trillion connections are your memories, behaviors, and thought patterns, how you move, think, and feel. How do these connections tell you where to find your keys, where you parked your car, or the name of the person you just met? In essence, how do you form and revisit a memory? Anytime you learn something new, Whether it was how to walk when you were a baby or how to use that new piece of technology, you make a connection between brain cells. Each brain cell can connect to about 10,000 other cells, which is why right now you have about 100 trillion connections in your brain. But how many connections did you have when you were 3? 10 times more than you do now. 1,000 trillion, a quadrillion. That's a number you don't hear every day. Between being born and turning 3 years old, connections are made at 10 to 20,000 connections a second. This explosion of connectivity is called synaptic exuberance. The process peaks somewhere around 8 years old. Then you start rapidly losing brain connections. But don't panic. This is a normal process called pruning, wherein the brain prioritizes which cell connections to keep and which to let go. Pruning allows your brain to both strengthen connections related to critical skills and information and form aspects of your personality. Think of your brain like a topiary bush or bonsai tree. During these critical years of developing, your brain is clipping away wayward foliage so that your personality, your interests, your likes and dislikes, and who you are at your essence can materialize. The key take-home message is that pruning unneeded connections happens during the developmental process to help your brain shape you into the person you are becoming. But the pruning process continues throughout your life as you make new connections and shed ones that are not needed. Think of your brain like your desk. You need to clear away the clutter to be productive. But clutter will inevitably creep back in, so clearing it isn't one and done. You'll have to clear it off again and again. Every night when you go to sleep, your brain eliminates connections it figures you don't need anymore. In Chapter 5, we delve deeper into how your brain retrieves the memories you want to access, like that famous actor's name, the guy in that movie, and, of course, more serious information. As you age, your brain doesn't change as rapidly as it did when you were a child, but it still dynamically changes all the time. Because your brain is malleable, you can make it more robust and more adaptable at any age to improve memory, manage stress, and boost focus and productivity. You can also transform your brain at any age to adopt new habits, gain perspective, and recover from physical and mental trauma. The great hope of life is that we are always a work in progress, able to get better and be better each day as our brain remodels. So, how old is your brain? We know that our brains are often not the same age as our chronological age. For instance, there's a group of people called superagers who are in their 80s and beyond but have the cognitive function of those decades younger. Conversely, it's possible for your brain to be older than your chronological age. Obviously, that's not something you want. While there's no test you can take at home to definitively say how old or young your brain is, although many online quizzes might tell you otherwise, most of those just aren't based in science. We can think of a young and healthy brain as being at peak function. And most often, peak brain function is associated with a sharp memory. As we get older, it can be difficult to remember names, faces, events, something we just read, or what we ate. In younger brains, the process called neural differentiation is efficient and robust. In this process, specific brain cells are tasked to remember certain types of information, such as faces. As we age, that process deteriorates, so the cells lose their specificity and do not function as well. Instead of just focusing on faces, they try to remember other types of information as well. For a superager, neural differentiation is akin to that of a 25-year-old. That's part of the reason why a superager has the memory performance of a 25-year-old. So, what else are the secrets of these superagers with robust memory, and all those with brain ages younger than their chronological ages? A study published in 2021 uncovered some surprising answers. Over 18 months, the study followed 330 people, referred to as superagers, who were 100 years or older. The researchers found no decline in most areas of memory or cognitive abilities. While a year and a half might not sound like a long time, once a person reaches the century mark, 2 years for them is like 25 years for a 75-year-old in terms of brain health. For example, the risk of developing dementia increases by 60% every 2 years after the age of 100, while it takes 25 years.
Sample complete. Ready to continue?